Alright, the topic of this lecture is multiplexers. And these are also commonly known as muxes. So you're going to hear this word mux a lot in the rest of this course. And another word for these are selectors. So multiplexers, muxes, they are just digital design elements that select one thing versus another thing. And they're really useful in digital design. So let's see what the structure of a mux looks like. Well, actually let me just first draw how we usually denote a mux. So a mux is typically denoted with a trapezoid like this. You put the select signals here. So this might assume there's two select signals. Then you put your inputs over here and your outputs over here. And there's always going to be a special relationship, again, just like in the standard decoders, between the inputs and the outputs. Alright, so let's say we have all these are 4-bit inputs. We're going to get a 4-bit output, and this is going to be our 0, 1, 2, 3. Okay, so what a mux does, let's say you put the number 1, or sorry, let's do 0, 0 on the select lines. What you're going to get on the output F is going to be whatever is connected to the 0th entry, which is A. So F is going to get A if you select 0, 0. If you select 0, 1, you're going to get B. If you select 1, 0, you're going to get C, and if you select 1, 1, you're going to get D. So this is how a mux is a selector. You have select pins, which tell you which piece of the mux are going to pass through the device. So here you have 4 different possible choices, and the mux selects among the choices. So how is this actually built? Well, let's look at the textbook. And a mux looks extremely similar to a standard decoder. If you recall, the standard decoder looks just like this. We had a bunch of AND gates and select pins. Now remember though, in the standard decoder we had separate outputs, and there was only one output on at a time. Now with a mux, what you do is you put your data signal on the same AND gate. So you can see here we have a data signal 0, data 1, data 2, data 3 going into these AND gates. And the output of each of these AND gates then all get ORed, so that way only one of them can be selected. Now by ANDing the data with the select signals, what you're doing is passing the data through the AND gate. So if your select was 0, 0, this would be a 1, 1 on this AND gate, the top AND gate here. And then depending on what data 0 is what would get passed through. So if data 0 or D0 was a 1, then you'd have a 1, 1, 1, which would give you a 1 output. And you would pass whatever the value of D0 is out through the output. Otherwise, if D0 was a 0, you'd get a 1, 1, 0, and that 0 would cause this AND gate to give you a 0 output, but then again, your 0 matches the 0 that D0 was. And so that gets passed through. So this structure, the standard decoder structure, also serves as your selector structure, but you add on the OR gate and your data coming into the AND gates. So let's see what a mux looks like in Vhdl. Here we have a mux called 4T1, which has a 4-bit input, a single bit output in this case, and a 2-bit select line. So what this mux is going to do is it's going to select which one of these 4 bits to send out to the output. So here's the entity declaration. Again, we show the 2 inputs D and cell and output F. And then the architecture. We're selecting a single bit, the 3rd bit of D, when select is 1, 1. We're going to select the 2nd bit of D when select is 1, 0. We're going to select the 1st bit when select is 0, 1, and the last bit, or sorry, the 0th bit when select is 0, 0, else 0. So this is just selecting which of the 4 bits is going to get sent to the output based on the select signal. So here is a VHDL example that looks more similar to what I had drawn in the notepad, where I have a whole bus being passed through instead of just an individual bit being passed through. So in this case we have the select signal, again in this case is 2 bits. We're going to have 4 inputs, each of which are 8 bits, and an output which is also 8 bits. So in this architecture of this mux, you can see with the select signal, with cell select, F gets AZ, which is one of the inputs, when it's 1, 1, AY when it's 1, 0, AX when it's 0, 1, and AW when cell is 0, 0, and this others get 0 when others means just 0 when others. The others right arrow single 0 is just another way of writing all 8 zeros. So this construct just sort of says, tell me how big the bus is and fill it with zeros. So because the output is 8 bits, this others get 0 will automatically give you 8 zeros when others. Okay, so what this mux is doing is the same thing that I drew over here on the bamboo paper, that it just, instead of 4, it has 8-bit inputs, and it selects one of the 4 to send to the output, as you can see. So the special relationship between the select signals, the inputs and outputs, are as follows. So the select signal, your inputs, number of inputs are going to be 2 to this number of select bits. So if I have 2 select bits, I'm going to have 4 inputs. If I have 3 select bits, I'm going to have 8 inputs, because it allows me then to choose among those 8. If I have 4 select bits, then I'm going to have, you got it, 16 possible inputs. And you're always going to have 1 output, because you're selecting among all of your choices. This is for a standard multiplexer.